Welcome to Section 10, Lesson 5. Mathematicians prefer fractions with rational denominators. The process of rewriting a fraction so the denominator has no radical is called rationalizing the denominator. Two main techniques cover almost every case. When the denominator is a single radical, multiply both numerator and denominator by that radical. The denominator becomes the radicand without a radical, and the numerator picks up the radical instead. The fraction's value does not change because we multiplied by something equal to 1. When the denominator is a binomial that includes a radical, multiply both top and bottom by the binomial's conjugate. The conjugate of a plus root b is a minus root b, and their product is a squared minus b. No radical left. Today's two examples cover the single radical case and the conjugate case. Both rely on the difference of squares identity from Section 8. Take 1 over the square root of 3. The radical is alone in the denominator, so the fix is one move multiply both numerator and denominator by the same radical, the square root of 3. Multiplying gives 1 times the square root of 3, which is just the square root of 3 on top. The denominator becomes the square root of 3 times itself, which is 3. So the fraction equals the square root of 3 over 3. Verify on the number line 1 over the square root of 3 and the square root of 3 over 3 are the same point, near 0.577, same value, different form. The general rule, a divided by the square root of b equals a times the square root of b, all over b, multiply top and bottom by the radical to clear the denominator. The numerator picks up the radical and the denominator simplifies to the radicand without it. Rationalize 5 over the square root of 8. Before reaching for the conjugate or anything fancy, simplify the radical first. The square root of 8 equals 2 times the square root of 2. The fraction becomes 5 over 2 times the square root of 2. Now multiply numerator and denominator by the square root of 2 to clear the radical from the denominator. The numerator becomes 5 times the square root of 2. The denominator becomes 2 times 2, which is 4. The fraction simplifies to 5 times the square root of 2 all over 4. Verify on the number line. 5 over the square root of 8 and 5 times the square root of 2 over 4 sit at the same point, around 1.77. Simplify radicals first to keep the arithmetic minimal. Example 2. Rationalize 1 over the binomial 2 plus the square root of 3. The denominator is not a single radical. Multiplying by just the radical does not clear it. Use the conjugate instead. The conjugate of 2 plus the square root of 3 is 2 minus the square root of 3. They differ only by the sign on the radical term. The conjugate's job is to produce a difference of squares. Multiply both numerator and denominator by the conjugate. The numerator becomes 2 minus the square root of 3. The denominator becomes 2 squared minus the square root of 3 squared, which equals 4 minus 3 equals 1. The fraction simplifies to 2 minus the square root of 3 over 1, which is just 2 minus the square root of 3. The conjugate trick converted a radical in the denominator problem into a clean integer and radical sum. 3 takeaways for rationalizing denominators. They cover every standard textbook case. Single radical denominator, multiply numerator and denominator by that same radical. The denominator becomes the radicand without a radical, the numerator picks it up, and the fraction's value is unchanged. Binomial denominator with a radical multiply by the conjugate. The conjugate flips the sign of the radical term, and the denominator collapses via difference of squares to a number with no radical. Always simplify the radical itself before rationalizing. A radical like the square root of 50 simplifies to 5 times the square root of 2. Rationalizing the simpler form takes less arithmetic and gives a cleaner answer.